Hey there guys, it's Mrs. Rubery, and today we're going to review three-dimensional geometry for the final that's coming up. So the first thing I want to look at is the difference between prisms and pyramids. So prisms are three-dimensional shapes that have two parallel bases, and all the faces are rectangular. So you can see that in the pictures there with the triangular prism, the square, the rectangular, the pentagonal, the hexagonal and octagonal. They all have two bases that are parallel to each other, and then the faces are all rectangles. The pyramids only have one base, and they're named after their bases, and the faces of it are all triangular, just different sized triangles that come up to a vertex or a point. Let's take a look at what nets are. Nets are a flat representation of a three-dimensional shape. So think about if you were to order some boxes in the mail, they're not going to come all folded up, just plain boxes. They're going to come flat, and you're going to need to fold the boxes up and tape them so that you can use them. So a net is like a flat unfolded box. So here is a net of a rectangular prism if I were to unfold it, and the color coding makes it real easy to see that the green is the front and the back, the red's the top and the bottom, and the blue are the two sides. Here's an example of a net of a triangular prism, and you can see that with the triangular prism, there's only two colors there, the green, that match, and that would be the two bases. So the triangle in the front and triangle in the back are considered the bases, and the three sides, the top, bottom, and side, are considered the faces of the triangular prism. Let's practice a little bit, taking a look at pictures of nets and trying to figure out what three-dimensional shape they came from. So in this example, the base is a square or a rectangle, and we have four triangular bases, and if you think of folding those upwards, they're all going to meet at a point. So this is a pyramid, and the bottom of it is a rectangle or a square, so we could call it a rectangular pyramid. Let's take a look at our second example. Okay, in this one, we have all six sides being a square. So this is definitely a prism. We could call it a rectangular prism, or more appropriately, because all the sides are a square, it's a special type of rectangular prism called a cube. Two more to practice with. In this one, now all of the shapes are definitely rectangles. They're not squares. So this one would be best classified as a rectangular prism. And lastly, in this one we have two triangles, and then all the faces are squares or rectangles. So this one would be a prism, and the name of the prism is by the bases, which would be a triangular prism. All right, let's shift gears into surface area of a rectangular prism. So when we figure out surface area, we're trying to figure out all that cardboard of the box. How much cardboard is there that we would need, or if we were going to wrap the box, how much wrapping paper to put over it, or if we were going to paint it, how much paint we would need to cover the surface of it. So surface area is not filling it up, that's volume. Surface area is the outside part of the box. So when we're doing surface area of a rectangular prism, all we need to identify is the length, the width, and the height. And I like to write those down so I can refer to them pretty easily. Now, as far as length, width, and height, if you get mixed up which one is which, it's okay because all the faces are rectangles. So if you have them mixed up, your formula is still going to work. So in this case, we have a length of 3, a width of 2, and a height of 6. And again, if those numbers are changed around, as long as you have the 3, the 2, and the 6, and you plug them in the formula, you're going to still get the correct answer. So my formula, the first part of it says that I need to take 2 times the length and width. So I'm going to do 2 times the length, which I got as 3, and the width that I got as 2. Plus, the second part is 2 times the length times the height. So I'm going to do 2 times the length, which is 3, and the height, which is 6. And the last part of the formula is 2 times the width times the height. So 2 times the width here, which is 2, and the height, which is 6. So I have all 3 parts, and now all I have to do is find my products and then add them together. So we got a 12 plus a 36 plus a 24. And when we add all those together, we get 72. The measurement, the unit is centimeters, and since it's area, it's going to be square centimeters. 72 square centimeters. Let's just look at one more example. So in this one, again, I'm going to identify what I want to call the length, the width, and the height. And I'm going to say 7, 2, and 4. And again, if you get them mixed up, it's okay. As long as you stick with what you identified your variables to be for your formula, it's all going to work out. First part is 2 times the length, which I got 7, times the width, which we have as 2, plus 2 times the length and height. 2 times the length, which again we got 7, and the height, which we got 4. Plus the last part of our formula, 2 times the width, which we got as 2, and the height, which we got as 4. We just need to find those products and then add them together. So we got 28, 56, and 16. And when I add those 3 together, we get 100 centimeters squared. Easy enough. Let's move on to triangular prisms, which are a little more difficult because we don't have the luxury of just figuring out or just putting anything for a length, a width, and a height. Because we're dealing with a triangle, you have to make sure that you figure out the base and the height of the triangle, the 2 other sides, and the width between the 2 triangles. So you do have to be very careful. So I have a couple easy ways for you to remember it. A, B, and C are the triangle, first 3 letters of the alphabet. The tricky part is A is representing the base. So remember, ACE is the base. H, like every other formula we've dealt with, H is the height, and W is the width, the distance between the 2 bases. Think of an accordion opening and closing. The width is the distance between those 2 triangles. So all we're going to do here is identify A, B, C, H, and W. So if A, B, and C, I'm going to highlight those, are the sides of the triangle, it might help to highlight the triangle in your picture. Remembering that A has to be the base. ACE is the base. Don't get it confused with B being used as the base in other formulas. So we have a 10 for the base. The other 2 sides of the triangle, we have a 13, and this side would also be a 13. The height is the height of the triangle. So I look at this dotted line, and it would be 12. And the width, remember, is the distance between the 2 triangles. So when I'm looking at the distance between them, we have it right here, which is 15. So that's a triangle, an isosceles triangle, where our height was a dotted line. Sometimes we have a right triangle. In a right triangle, one of the sides of the triangle is also the height. So it has to do double duty. Take a look at this triangle. I'm going to highlight it in green. The base of the triangle is here at 5. The height of the triangle, I'm going to go right to that, is 12. But that's also a side of the triangle. So I could put that as B or C. These 2 are interchangeable. The other side of the triangle is right here, which happens to be 13. For the width, we're looking again for the distance between the 2 triangles, and we can see that it's 9. And then we would plug it in our formula. Okay, let's try one more. This one, let's do the formula with it to find the surface area. Okay. So we have ACE is the base, which would be 9. B and C are the other two sides of the triangle, 12 and 15. And again, those two could be interchangeable. H is the height of the triangle. Remember, we're doing double duty because this is a right triangle. So the height and the base are perpendicular. So the height would be 12. And the width is the distance between the two triangles. In this case is 16. So now we just need to follow our formula. So we have A times H. A is 9 times H is 12 plus, change my color, A times W. A is 9 again, and W is 16. On to the third part of our formula, B times W. B we identified here as 12 and W as 16. And the last part of our formula, C times W. C we identified as 15 and W as 16. So now we can just multiply these, and you are allowed to use a calculator for the geometry, so the calculations don't hold you up on what you're trying to find. So 9 times 12 gives us a product of 108. 9 times 16 gives us a product of 144. 12 times 16 is 192. And finally, 15 times 16 gives us 240. And all I need to do is add those all together. So 108 plus 144 plus 192 plus 240 gives us a surface area of 684. This is in feet, and remember it's going to be squared because it's surface area. And one more little time to climb to practice. A couple of review questions. A shape with two parallel bases with the shape of a triangle would be called. So if it has two bases that are parallel, we're talking about a prism, and it's named from the base, triangular prism. Next question. If I have a shape with 6 rectangular faces, they're all rectangular faces, then we're talking about a rectangular prism. If a triangular prism surface area problem, or in a triangular prism surface area problem, which variable represents the base? Remember, ACE is the base, so A is the base. And finally, question number 4. In a triangular prism surface area problem, which variable represents the distance between the two triangular bases? And A, B, and C are the sides of the triangle, so it must be W. The width is the distance between the two bases. And that concludes our quick review of three-dimensional geometry.